Hello everyone, welcome to series lectures of Basic Electronics. Myself Hamid Sakhwara, and today in this video lecture we are going to discuss about N-channel JFET's characteristics. So it is totally dependent on previous lecture because we have seen N-channel JFET's working principle and its operation. So here in this topic we are going to draw its characteristics. So let us start with three different types of cases as we discussed in previous lecture. So here we can see these are the three cases. Case number one, where depletion region is smaller because we applied VGS is equal to 0, as you remember that. Then after, in case number two, we can see here we apply more negative voltage, that means -1, -2 we can say. That's why its depletion region is increased. So here we can see in case number 2, depletion region is penetrated more in N channel. So that's why the flow of ID, here we can see ID flow, that means it is drain current. Its flow of ID is reduced due to this depletion region. Then after, in case number 3, here we can see if we apply more and more negative voltage, that means we can say VGS is equal to -4 and -5, then depletion region touches together. Here we can see the width of depletion region is maximum. So at this time your flow of current, your flow of drain current becomes 0. So ID is equal to 0. So on this working principle we are going to draw characteristics. So here it is most important to draw characteristics of N-channel JFET. So remember these three cases, we are going to use it in graph. So let us start with its characteristics. Now here N-channel JFET characteristics we can see here, it is basically drain characteristics, or more precisely we can say it is output characteristics, because here output voltage on x-axis and output current at y-axis. So here we can see the characteristics of JFET is defined by the plotting a curve between the drain current, which is at y-axis, ID, between the drain current and drain source voltage. So here we can see it is the VDS. So with respect to voltage applied at drain source terminals, keeping the gate source voltage constant, then we will draw this characteristics. That means basically it is the graph of ID versus VDS. Now here VGS is negative. Remember this thing, in N-channel JFET we should take VGS in negative. So here we can see this is the characteristics. Let us start with its characteristics. First, if we applied VGS is equal to 0, as we discussed in our previous lecture, that if we shorted two terminals, gate terminal and source terminal, that means VGS, it is also equivalent to VGS is equal to 0. So at this time the depletion region is not penetrated in N channel. That's why your flow of drain current is maximum. That means we also say it is ID is equal to IDSS. That means drain to source saturation current. So it is at peak level. So here we can see in this characteristics at VGS is equal to 0, at this time your ID is maximum. Here we can see it is your ID maximum. Then if we applied in case number 2, remember this thing, if we applied VGS in negative, or we can say we applied small VGS. At this time, here we can see the depletion region is penetrated slightly in N channel. That is obstacle for the drain current. So it means your flow of drain current becomes reduced. Here we can see in characteristics, if VGS is equal to -1 volt, at this time your IDSS becomes your ID here. We can see here in this characteristics. So basically ID is reduced in this characteristics. If we applied more negative voltage like VGS is equal to -2 volt, then after it also decreased here. Then after VGS is equal to -3 volt, so it reaches at this point. And if we apply more and more negative voltage, VGS is equal to -4 volt, so at this time your drain current flow reduced. Here we can see in this characteristics why it becomes reduced, because we have seen in our previous lecture that the width of depletion region is increased when you give more and more negative voltage. So here if we applied more and more negative voltage, VGS is equal to -1 to VGS is equal to -4, at this time we can see ID, that means drain current flow, is reduced. Now here we can see it is divided into 3 different types of region. So let us discuss about first this region. It is known as cutoff region. So at this region, cutoff region, your drain current is equal to 0. It is approximately 0. That's why it is known as cutoff region. Now here we can see this is the new region introduced in this characteristics. Before that we have seen only 3 regions, which are saturation region, active region and cutoff region, which is introduced in transistor, or we can say BJT, NPN and PNP transistor. But here it is the FET type. So in this characteristics we are going to discuss about only 3 regions, which are cutoff region, ohmic region and saturation region. So here I am going to introduce new region which is called as ohmic region. Here we can see in this graph it is the ohmic region. Ohmic region, it is the according to Ohm's law, because R is equal to V by I. That's why it is linear in this graph. Here we can see it is linear. So that region is known as ohmic region. Now after this ohmic region, we can see clearly here P point to Q point. Here we can see P to Q point is slightly changes in ID with respect to VDS. When we increase VDS, there is a slight change in drain current. That region is known as saturation region, or we can say it is known as pinch off region. So this is the second and we can say third region of this characteristics. First one is cutoff region, second one is ohmic region and third one is saturation region. But after this saturation region, if we are going to continuously increase VDS value, after some point, here we can see after Q point the graph is bent from here. So it is known as breakdown region. So after this region your transistor becomes damaged permanently. So here we can see it damaged permanently because it is breakdown. So here we can see this portion is known as breakdown region. So this is the characteristics of N-channel JFET. Now in N-channel JFET we discussed about ohmic region. Here we can see it shows linear response and drain current is opposed by the JFET transistor resistance. Second one is saturation region. Third one is cutoff region, and final breakdown region. These are the definitions of ohmic region, saturation region, cutoff region, and breakdown region. So you can read from these definitions. Here now we are going to discuss about another characteristics which is known as transfer characteristics. Now transfer characteristics is a little bit different to the output characteristics. Here we can see this is the graph versus ID versus VGS, whereas in output characteristics or in drain characteristics it is the graph ID versus VDS, but here ID versus VGS. So we can plot transfer characteristics with the help of output characteristics. So if we plot first output characteristics, then we can precisely plot transfer characteristics like this. So this is the transfer characteristics, and we can draw it according to Shockley's equation. So what is Shockley's equation? It is ID is equal to IDSS in bracket 1 minus VGS upon VP bracket complete whole square is known as Shockley's equation. So let us discuss about first transfer characteristics. How can we plot transfer characteristics from output characteristics? So we can conclude that from this graph. Here the relationship between the VGS and ID is known as transfer characteristics curve. Here we can see this is the drain characteristics, or we can say this is the output characteristics of N-channel JFET, which we have plotted already before. Now here first VGS is equal to 0. We are going to start with this VGS is equal to 0. First of all, we have to remember this thing. On x-axis here, we have to plot different values of VDS. At y-axis, we have to plot values of ID, drain current. But for transfer characteristics, at x-axis, it should be the values of VGS. So these are the transfer characteristics. Now we have to start with VGS is equal to 0. First VGS is equal to 0. At this time there is no depletion region, so the flow of drain current is maximum. So here we can see IDSS is 12 milliampere. If we gradually decrease VGS value in negative side, VGS is equal to -1 volt. That means the depletion region is penetrated more into the N channel, and that's why it is become obstacle for the flow of drain current. So here we can see drain current is reduced, so it becomes 7.68 milliampere. Then if we reduce more and more VGS is equal to -2 volt, VGS is equal to -3 volt, and VGS is equal to -4 volt. At this time, your graph of ID goes to reduced more. So like this, we can plot transfer characteristics from the drain, or we can say output characteristics. So next, here this is the similar to the N-channel JFET. So here we can see this is the P-channel JFET symbol and its construction. As we discussed in previous lecture that we have to change only here polarities and it becomes P-channel JFET. Here we can see in this construction, first polarity is plus, and here it is connected to the P type material. So here we have to change, or we have to inverse the polarities of N-channel JFET, then it becomes P-channel JFET. So here we can see this is the symbol of P-channel JFET. Similarly, here we can see P-channel JFET's characteristics as we discussed for N-channel JFET's characteristics. But here we can see in this graph it is the in second quadrant, because here we have to apply minus value of VDS. That's why here it is available in second quadrant. This is the graph of ID versus VDS. Here we can see first region is known as ohmic region, then after it becomes saturation region, and final we can see that is breakdown region. And here in below VGS is equal to, here we can see 4, and below VGS is equal to 4, it is known as cutoff region. So like this we can plot P channel JFET characteristics, but remember this thing, it should be in second quadrant because we are showing here minus values of VDS. So here is the transfer characteristics comparison between the P channel and N channel. Here we can see this is the P channel JFET's characteristics, and here we can see this is the N channel's JFET characteristics. So similarly we can plot P channel's JFET characteristics from N channel JFET characteristics. So that's all for today's lecture. If you have any query related to this topic, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in next coming lecture. Thank you.